I'm Paul Welch. I'm a SVP of Product Engineering at Redapt. We're a systems integrator that does a lot of work in the cloud as well as data center and all the way up the stack. So we pretty much cover the full space of what Cloud Native talks about. And I thought it might be nice today to take a step back a little bit and see the forest through the trees and talk about why we're all talking about Cloud Native. And how Cloud Native can really help you innovate faster and grow your business. Some of this are not new ideas. It's been around for a while, but you might be surprised to hear how critically important it is in the new economy to your business and to your ability to compete in the market. So, what if I told you, in the vein of start with why, what if I told you you could delight customers, grow your market share, increase revenue, and develop new opportunities for your business? And all you need to do is change the way that you think about technology. And that's the opportunity we have with Cloud Native, and what I hope by the end of this talk you'll see the vision that I have. So Redapt, as I said, we're a systems integrator, and we focus on helping our customers to adopt a lot of the new technologies that come along and really get the most benefit from them. And so Cloud Native is something that we as a company have been working with for quite a while. We've been doing production deployments and using Kubernetes at pretty large scale since 2015, which is, I believe, even before Kubernetes open source was 1.0. So I have quite a bit of experience. Personally, I'm very into innovation and the whole process of taking an idea and bringing it to market. I do that at Redapt, and I also am part of an advisory board for a local college program here on innovation. I've been in the industry for a long time and have seen many waves and cycles. As Ron was talking about, a lot of these topics or a lot of these innovation cycles, they're kind of like the pendulum. They swing back and forth, and you'll centralize and then decentralize and then centralize again and so forth. And so I've seen many iterations of this, and so I think it gives me good perspective as well as some context for Kubernetes to how the current cycle is going to go. So what I'd like to do is start with some trends, and this is not something new. I've been hearing for probably 20 years that all companies are tech companies in some way or another, and it means something different today than it did 20 years ago. When I heard this 20 years ago, I think I heard a pretty famous Bill Gates speech where he talked about all companies are tech companies, and at that time what it was really more focused on was you need to sell your products online and have an e-commerce site. You need to use analytics to optimize your business and reduce costs. But if we fast forward to today, what it really means today is much more strategic, much more important and integrated into your product, your core products that you sell to customers. It's so important, in fact, that one Accenture report says that companies that are good with technology, good with this process of building technology into their products, have twice as much revenue growth as companies that don't. And the way that we develop new, technology-enabled products and integrated products is the process of innovation. So as I said, technology is driving revenue, and that's through smarter products, whether it's using AI to make your customer-facing products smarter about recommendations, or providing a better user experience in your website that saves the customers time when entering their orders, or maybe even creating entirely new product categories like interactive exercise equipment or self-driving cars. It's all about technology innovation, and that's driving new features and products to market. And driving new products to market the speed at which you do that, I refer to that as the velocity. And the velocity is what's important. You hear that in Agile a lot as well. It's how often can you get things through the process. And for innovation terms, this chart shows the relationship between profit growth and amount of innovation done by your company. And the specific numbers don't really matter as much as the trend line, which you can see is up and to the right. And that's usually what you want in graphs, up and to the right. It seems intuitive when you see the data on the graph, but maybe not as obvious when you take a step back when you're prioritizing budgets and you're in the details. But simply, companies that do more innovation grow their profits faster. And I couldn't talk about this without mentioning COVID, of course. We've all seen the effects of COVID over the last couple of years. One interesting impact to us as technologists has been the increasing pressure that it's had to do everything online and remote. Shopping, services, scheduling, business meetings, even webinars like today, which used to be in-person events. They're all online now. And that's driving innovation and technology advancements, new products to enable that new type of interaction. So, creating value and increasing your competitive advantage is tied to your ability to innovate, which means launching new features and products and apps faster. Easy, right? Just go faster. But hold on a second, it's not so fast. According to many studies, a very significant portion of everyone's technology budget is usually tied up maintaining legacy systems. In fact, over the years and decades, mission-critical systems have been developed and are still out there helping to run the business, and you can't just throw them out the window. You can't ignore them without serious impact, sometimes financial, to the business. It's technical debt. Everyone's probably heard that term, right? It's what's preventing you from taking that budget to maintain them and investing it into new features and new products. And what's worse is many companies over the years have tried and failed to recoup part of that 70% of technical debt budget by investing in improvements. That's the right idea. Unfortunately, many have done it poorly, according to studies. Using cloud just like your data center, or lift and shift, which really delivers no new functionality, or DevOps done poorly sound familiar? Accenture says only 13% of businesses are getting the full benefit of their investment, and many other studies confirm. I really like Puppet's annual report, State of DevOps. If you haven't seen it, you can. It's pretty easy to find and download. It's free. Excuse me. And in their most recent report for 2021, they said only 20% of companies that have gone to the cloud are getting full potential. That's a big investment for not getting the full return on that investment. And honestly creating more technical debt rather than reducing it. So enter cloud native. That's exactly the challenge cloud native is designed to address. Done right, it will allow you to innovate at a pace that's hundreds or even thousands of times faster than traditional approaches. Studies show that adopting and effectively using cloud native tools and processes helps you to achieve more frequent deployments with less lead time and less failures. So what is cloud native? If we take a look at the definition provided by CNCF, the Cloud Native Computing Foundation, that's the standards group that coordinates all the standards and definitions and all the different working groups that contribute to the open source project. They provide a definition in their GitHub wiki page, and honestly, it's pretty generic on purpose, I think. They didn't want to be overly prescriptive about specific tools and architectures, but we can glean some important criteria about what it is from their vision. The definition says cloud native runs in modern dynamic environments. That refers to the infrastructure used to run the applications. It doesn't dictate that it's cloud or containers or specifically what it is, but it needs to be modern and dynamic. And it talks about what qualifies, whether it's bare metal virtual machines, a cloud service, Kubernetes. It should be dynamic, which to me means treating your infrastructure as code. It needs to be provided in a self-service and automated way. And it talks a lot about automation. Apologize, I'm having some scrolling issues here. Automation at all layers is really, in my opinion, one of the key ingredients. The Puppet report that I referred to, it actually said that automation is not enough, it's not sufficient, but there is a very high correlation to companies that are doing this well and how much automation that they've deployed. The definition also talks about app development techniques in the second paragraph here. And the techniques are referring back to prior examples like containers and microservices, also building in scaffolding that allows more agile development and increased code velocity. And again, they refer to robust automation at the application layers, doing continuous integration and delivery, making things more predictable and higher quality. And then the last thing that's highlighted here, this one's really important. It says the goal is to allow engineers to make high impact changes frequently, more predictably, and with minimal toil. Right, so that's exactly what we were just talking about. It is needed to increase your velocity for innovation. So you might have seen this if you're familiar with CNCF. They have a cloud native landscape. They've organized different functionality into domains within the ecosystem of what are all the different things that you need to create this vision. And within each of the buckets, they've got hundreds or thousands of both open source and commercial products that fill those criteria. In fact, I looked at it, throwing the slide together, and I was surprised to see over 1,000, solution cards in here, and with a market cap for the commercial products of over $17 trillion. That's a big jump since the last time I looked at it. It's growing fast. So there's a lot there, right? What does it? How do you piece all this together? And I'd like to focus in on some major categories of the landscape that help you decrease the time to value. Time to value, it's just another way to say how fast you're innovating or how fast you're bringing new features to market. What's the amount of time it takes to get from an idea to a real feature running in the user's hands in front of the user? And because today's theme is about applications, I'll focus mostly on that area. So, the development process itself, I've been around for a while, and I've actually seen firsthand and worked through all of these stages myself. I spent many years building monolithic applications in a waterfall process, being deployed by an entirely different team with a throw it over the wall, elaborate handoff. And it took months. It could be, weeks, 4 to 6 weeks maybe, to procure servers, and months of development because of all the entangled code and dependencies, weeks of formalized testing, and usually a full weekend to deploy it because we couldn't take the system down and have downtime during business hours to do the upgrade. So over the years, we've had a lot of improvements, working with virtual machines and better software architectures, but nothing like nothing that I've seen like the cloud native vision. If you go all the way to the bottom here and focus on the last row of the combination of doing microservices architectures with DevOps processes, with containerized deployment packaging and deploying to a self-service infrastructure like cloud and Kubernetes, it's just an amazing difference. And that's how you get from taking months to take that idea to market to doing it every day or even multiple times per day. So Ron, I want to do a quick time check because I know I only had 20 minutes, but I didn't actually note what time I started.
Oh, you can go 5-10 minutes. We're okay.
Okay, cool. So I won't skip over the next couple slides then. Each one of these bullets could actually be a talk all by itself, probably. They're pretty large topics in themselves, but I wanted to give a few ideas and examples of what it means to have a cloud native architecture and show kind of what that results in. So you've heard a little bit about microservices already today. You probably have some ideas of some of these. Highly recommend the 12-factor app set of patterns. That's a really good starting point if you're just getting started. And the summary of this, in my opinion, is the decoupling and encapsulation of the scope of things. So when I think of microservices, or without starting a debate of what size is how big or small a microservice should be, right-sized services, it encapsulates that both functional domain for the developers to focus on with their code, as well as the complexity, which a lot of complexity formulas focus in on how many touch points does object A have with object B or C, right? And by drawing a boundary around that service, you're really reducing the complexity by reducing those touch points and making them looser and well defined. So that helps the developers code faster. It also, when it gets time to deploy it, it also means that you can deploy it independently. So instead of if you have this huge monolith code base and it's got the equivalent of 10 or 20 or 100 different services all bundled into one deployment package, then all of those things have to be ready to deploy at the same time and deployed together. Whereas microservices you can deploy whenever your microservice is ready to deploy, which is much faster. And then, as a similar note, it's when it's deployed out there and running in production, if problems happen, whether it's a bug or a security breach or any other problem, the blast radius or the impact of that is contained within that microservice rather than the entire application. So it could be, as an example, just one feature of your website has an outage or a bug instead of the entire website is down. So in the development process itself, similar list of examples and tools, and the benefits I'm pointing to another annual report by a group called DORA. They're part of Google now, but they used to be an independent research group. Some PhDs that really did study and focus on the benefits of DevOps style development processes. And they wrote a book a couple of years ago. I believe the title is Accelerate. But they've always got really good metrics about where the industry is and what performing at a high level in these categories means. And their current metrics from this year show companies that are doing this well deploy 973 times more often than companies that don't. That's a pretty big number, but it makes sense if you think of the months. There are still companies out there that are taking months to go through a cycle and deploy a release, versus companies that are deploying many times per day. In addition to just how fast you deploy, you can do that and still not lose your high quality. So the DORA report also shows when these deployments happen, companies that are doing it well are 3 times less likely to have a failure with that deployment. And even if there is a failure, they're thousands of times faster recovery time because it's so much easier to troubleshoot one service that's running independently than it is to troubleshoot the giant monolith where the problem could have happened anywhere in a very large code base. So there's so many pieces to this, it's really hard to know where to start. And even if you've dipped your toe in the water, it's still a pretty big ocean of things to look at. So I just wanted to mention quickly, the way that we normally help our customers get started is using an iterative approach based on a maturity model. We've developed a variation of that in-house. We call it Technology Maturity Framework. But it's really based on many other maturity model concepts of defining some criteria that tell you how well you're performing and your capabilities on the different subject areas, and then helping you put together an iterative step-by-step approach to improving your capabilities and getting incrementally to each next level. So I just wanted to mention that it's important to not bite off too much all at once, in my opinion. And I think the secret is to find one thing that you can improve, do it, learn from that experience, and then take the next step one at a time. But remember, delivering the features and new products to market is what drives innovation and revenue. And a cloud native is a very holistic view across the organization of how to do all of that faster. There's many, well-documented use case studies out there of companies that have done this, done it well, and used it to capture great market share. So you can definitely get improvements by just picking one or two or individual cloud native pieces of the puzzle, and that will get you incremental benefits. But the real magic happens when all the pieces come together and it's implemented across the organization. So I'd like to thank everyone. Again, my contact information is there. I have the wrong link. We also focus on artificial intelligence and ML. So that's the landing page for that. But if you look on our website, we do have a landing page for cloud native and all of these tools and technologies that I'm talking about.
Oh, that was great, Paul. Thank you very much. The real power of Redapt is its technical expertise, and yet it's also hands-on approach for helping the largest of organizations deal with the most complicated of issues while still retaining that ability for your team to directly interact with experts like Paul. Anything else you want to add, Paul?
No, just I want to say thanks to everyone for joining, and I'm open to anyone that wants to reach out to dive deeper, and happy holidays to everyone.